Everyone, today I'm going to talk about question number 6. Question number 6 states, in this accompanying figures, two secant intersects in the interior or exterior of the circle. In each case, find the angle alpha formed by the secants in terms of measures of the intercepted arcs. State and prove the corresponding results. I also put that secant, it's a line that intersects 2 points on the circle. So this is one example here. You can see here that this is a secant line, and then you have the chord and radius, diameter, and tangent. I also added the definition of an inscribed angle theorem, which is a 3.2, which is an angle with the vertex on the circumference of a circle and its sides formed by two chords, or and whose vertex is on a circle and whose sides are chords of the circle. So this is one example here that describes angle and the intercept arc. It's going to be right here. And then this is angle ABC equals 1/2 of arc AC right here. I also added this other picture here, inscribed angle theorem. So this is a visual representation of the inscribed angle theorem. So inscribed angle is always 1/2 the measure of either the central angle or the intercept arc, sharing endpoints of the inscribed angle sides. So right here, that's the intercepted arc, the central angle, and this will be the inscribed angle side over here. I also put this picture here. This is another theorem, the secant theorem, which states given two secant segments which share an endpoint outside of the circle, the product of one secant segment and its external segments is equal to the product of the other secant segment and its external segment. So there's another picture here. So in this case, PA times PB equals PC times PD. So going back to the question, they want us to find and prove the angle A form alpha. I'm sorry. So right here they want to get the measurements of this angle here and over here. So this is my proof right here. So suppose that in circle O, or in a congruent circle, measure angle BAC is exterior of circle O by secant theorem E times EB equals AD times AC, making it congruent with segments AB congruent to AC. So once again here, this is the circle, the congruent circle, and then it's going to be measure BAC, which is outside the circle. So in this case, I decided to include the secant theorem, which states that AE and times AB equals AD, and after that times AC. Okay, making it congruent from AB, and AC will be congruent. So AC and AB are congruent. So I decided to apply the SSS theorem. This makes all the three sides equal and its corresponding angles equal. Now let's say measure angle BA prime C equals 100 degrees. By the inscribed angle theorem 3.2 states that in inscribed angle is always 1/2 of the measure of the central angle or the intercept arc sharing endpoints of the inscribed angle sides. So in this case, BAC will be the inscribed angle, and B prime A C will be the center angle. So for example, if BA prime C angle is 100 degrees, by the inscribed angle theorem, we will have to divide by 2. So making the measure of angle BAC making it this 50 degrees. So in this case, the question is asking to find angle alpha with measures of intercepted arc. So if this be prime C is 50 degrees, also the intercept arc will be 50 degrees. So measure angle BAC equals 1/2 arc BC. So as stated before, inscribe angle BAC is half of arc measure BC. So if measure angle B A prime C is 100 degrees, then arc measure BC is also 100 degrees. Make it inscribe angle 100 degrees divided by 2 equals 50 degrees. Lastly, measure angle BAC equals 1/2 intercepted arc BC. For the other central circle, so this is the other part. I got measure angle CAD is the inscribed angle, in which measure angle C prime, A prime, D prime is the center angle. This includes core lines A prime, C prime, A prime, D prime, and AC and AD. So this will be C prime, A prime, and D prime will be the central angle, and then CAD will be the inscribed angle, and this will be right here the intercepted arc. And then it's going to be the chords A prime, C prime, AC, AD, A prime, D prime. So once again, we need to find the alpha angle. This one right here. So we know that by the inscribed angle theorem that measure angle CAD equals 1/2 arc CD equals 1/2 measure angle C prime, A prime, D prime. Therefore, alpha equals 1/2 arc CD. So once again, C prime, A prime, D prime. Let's say this is 100 degrees. You divide that by 2. This will be CAD. Will be 50 degrees.